Hello everyone. On this video we will cover shifting graphs. Okay, so starting off, first thing we're going to do is we're going to review some pretty common graphs. Okay, so first we're going to make our XY axis. There's your X and there's your Y axis. Okay, and going up like that, this is the graph of f of x equals x. Okay, now if we create another XY axis, okay, we have X and we have our Y. The graph here even though it's not perfectly drawn, that's your f of x equals x squared. Alright, so just go ahead and draw a line up under here. Move that up a little bit. If we draw another XY axis, again we have our x and we have our y. We draw two straight lines going at an angle away from the origin. This is f of x equals absolute value of x. Okay, so if we draw another xy axis, you have your x and you have your y there. This graph here this is f of x equals x to the third power. Clean up that 3 just a little bit. There we go. Okay, and last but not least, we draw our, let me move that up a little more. We draw our x and y axis again. And this graph looks something like this. This is our f of x equals square root of x. Okay, so you have your f of x equal, or you could say y equals x squared if you like. But most questions at this level shows it at f of x. Okay, but again, if you want to think of it as y equals x to the third, y equals absolute value of x, y equals square root of x, you can. But you want to kind of get adjusted to the f of x as soon as possible, because a lot of the times that's how the questions will be written out. So it's pretty good to know how it looks and be comfortable with it. Okay, now to do this section, you want to make sure you recognize all of these graphs. So if you have to practice drawing them over and over just to get familiar with them, that's a really good practice. All right. Okay, so if you're still writing this, feel free to press pause. I'm going to go ahead and we're going to go to our first part. And this part will cover vertical graph shift. Okay, so we have our vertical graph shift. And with our vertical graph shift, we know that a function that we'll call f of x will shift up c units. Remember, c just represents a number. It could be 1, 2, 3, 4, 20, 100. That's why instead of saying a number, we just call it c. When, let's say, some function we'll call h of x equals that f of x plus whatever that c value is, that's assuming that c is greater than 0. Okay, now a function, and kind of separate that a little bit. F of x will shift down c units when, we'll say, h of x, clean that up a little, equals f of x minus c, and again, that's assuming that c is positive. Okay, and the reason we're saying c is positive, because if you have minus -4, then it's just going to become plus. So that's why here we say c is positive, because if you have something plus -8, that's just something -8. Something minus negative just becomes plus, so it keeps from confusing. You just make sure that c is positive for our plus and our minus. Okay, so now we're going to go ahead to our first example. All right, so let's say for our first example, we want to graph f of x equals x squared minus 3. Now, in some cases, you may have a multiple choice problem, and they'll give you 4 or 5 graphs to choose from. You have to choose this one. This will kind of show you the process. Or sometimes you may have to actually draw it out. Okay? So the first thing we're going to do, we're going to find what we call the parent function. Okay, so a quick note. Find your parent function by removing all constants. Okay. Now, by the constants, we don't mean the exponents. Do not remove your exponents. Okay? Okay, so now we're going to look at where we started. Our f of x equals x squared minus 3. Okay. Now here, the only constant we have that's not an exponent is the minus 3, which here means we're going to remove it. So that leaves us with f of x equals x squared as our parent function. Okay, So now we're going to go ahead and draw f of x equals x squared. And if you look back on our first sheet from our common graph, that's this one here. So we're going to go ahead and draw that one. Move that up. There we go. Okay, so if we draw our parent function, we have our x, and we have our y. Our f of x equals x squared looks like that. Okay, so this is f of x equals x squared. Okay, so now you're looking at f of x squared minus 3. That's what you want to graph. So if you look up here, you have your f of x minus some value, which is our c. So that means since it's minus c, it's going to shift down c number of units. So since it's f of x equals x squared minus 3, the x squared is going to shift down 3 units. Okay, so I'm going to draw that out and show you exactly what I mean. Okay, so you have your x and you have your y. And I'm just going to draw a dotted line of our f of x equals x squared. So, excuse the uneven looking graph. Okay, so we're just going to say this is our f of x equals x squared, which is just here. Okay, that graph is going to shift down 1, 2, 3 units. So we'll say that's our -3, -2, and -1. So that whole graph is just going to shift down. So that means this graph will look like this. Okay, so we just got that whole thing and brought it down 3 units. So this right here will be your graph of f of x equals x squared minus 3. Okay, and if you like, you can erase this right here if it's confusing you or in your way, the dotted graph. But this is the graph right here. And a little circle around that. All right, so what we're going to do, we're going to go ahead and do another example. If you are still writing, please feel free to press pause. All right, bring our paper down a little. Okay, so let's say, for example, we want to graph f of x equals absolute value of x plus 4. Okay, so remember from the last example, the very first thing you do is you want to find your parent function. Okay, so we know that f of x equals absolute value of x plus 4. We're going to drop that constant. So we're going to remove this one. And that just leaves f of x equals absolute value of x as our parent function. Okay, now if you go back to the very first page of our common graph, okay, absolute value of x is right here. So that's our f of x equals absolute value of x. Okay, so we're going to go ahead and draw that one. And we have our x and y axis. And our f of x equals absolute value of x looks kind of like that. F of x equals absolute value of x. Okay, now from there, we're going to draw our x and y axis. Okay, and just like before, I'm going to draw kind of a little light dotted parent function. That's our absolute value of x, just to kind of show you where we are. 1, 2, 3, 4. Oh, let me move this up so it won't interfere with our graph. This is your parent function, a little circle around that. Okay, so we get our parent function, and since this is absolute value of x plus 4, we're going to get that and move it up 4 spaces. So this is our 4 here. Okay, so that means we get this whole graph and shift it 1, 2, 3, 4 up. Well, that should look a little more symmetric than that. And sorry, but drawing and sketching is not my strong suit. But hopefully you get the idea. That entire graph is shifting up. Okay, so that means this graph here is f of x equals absolute value of x plus 4. So hopefully this is starting to make a little bit of sense. Alright. So I'm going to do the next example right up under this one since we have over a half a page left. Okay, so let's say for this example, we wanted to graph f of x equals square root of x plus 2. Okay, so using the last two examples, I want you to press pause and graph this one on your own. Alright, so I'm assuming you've already pressed pause and you have worked this problem out. So let's go ahead and work this one out. Okay, so we have f of x equals square root of x plus 2. First thing you have to do, remove all the constants. And that will give us f of x equals square root of x, which is our parent function. Okay, so we have our parent function. All right, so let's go ahead and shift this up. And if we draw our graph of our parent function, x and y, and again, looking on our very first page, f of x equals square root of x, square root of x, kind of looks like that. Okay, so it looks kind of like that. So that's our f of x equals square root of x. Okay, so that means there we draw our xy axis again. And we know we're going to go up 2 spaces because that's our function plus 2, our parent function plus 2. Our f of x equals square root of x kind of looks like that. So we're going to get that graph and shift it up twice. So that means this is actually our f of x equals square root of x plus 2. Okay. And again, if you want to erase the little dotted parent function, you can. So that's the first part, our vertical shift. Okay. So if you are still writing, please feel free to press pause. But we're going to now look at our horizontal shift. So that's shifting from left to right. Okay, so now we look at our horizontal graph shift. Okay, now for our horizontal graph shift, it's a little bit different than the vertical graph shift. And I'll point out exactly why it's a little different. Okay, so f of x will shift c units to the right when h of x is equal to f of x minus c. Now that's why it's different. When it's f of x minus c, it's going to shift to the right. Okay? Now you would think on an xy axis, it's pretty common to want to automatically shift it to the left because of the minus. But no, when it's c units to the right, well, it will shift c units to the right when you have f of x minus c. Okay, so you definitely want to remember that little bit of a change when it comes to shifting it left and right. Okay, now f of x will shift c units, add up a little, to the left when h of x equals f of x plus c. All right. Now I'll give you a few examples of how this looks as opposed to what we did before. Okay, so let's say, for example, if we have f of x equals x squared. Okay, so that means we have f of x equals x minus 3 squared. Then we're going to shift it 3 spaces to the right. Shift x squared 3 spaces right. Remember, that's f of x minus c. Okay, so that's x squared, that's x minus 3 squared. So that's x minus some value c squared. All right, so give another quick example. let's say if we have f of x equals absolute value of x, but instead we have f of x equals absolute value of x plus 8. Now this one would shift absolute value of x 8 spaces left because that's plus c. So that'd be plus 8, so you shift absolute value of x 8 spaces to the left. Alright, so hopefully that's starting to clear up the difference between the vertical shift and horizontal shift. Alright, so right now what we're going to do is we're going to go ahead and do a few examples of this. Okay, we have a little space left on this page, so we're going to go ahead and use it up. Okay, so what if we wanted to graph f of x equals x minus 4 squared? Alright, so just like before, when we're graphing, nothing else changes as far as the steps we use to graph. Okay, so if we start off with our f of x equals x minus 4 squared, remove all constants, but we leave our exponent, so that exponent doesn't get touched. Okay, so we're going to remove this one. Remove that minus 4. So that means f of x equals x squared is our parent function. Okay, so a lot of times, get a process. Stick to that process, you'll see, okay, it'll work out a little bit. Okay, so once we find our parent function, go ahead and graph our parent function. Okay, so we get our xy axis. We have our x, and we have our y, and f of x equals x squared. Kind of looks like that. Okay, so we drew our parent function. So now we're just going to get that parent function, and since it's, oh, I moved it up a little bit, go down. X minus 4 squared, that's our f of x minus c. So that means we're going to shift that to the right. C number of units, or in this case, 4 units. And the reason we say units, because we don't know if it's inches, feet, whatever, so we just say units to cover everything. Alrighty, so if we draw our xy axis, that's our x, and that's our y. And again, if you want to, you can draw your parent function right there. Okay, so this one, we're going to shift this 1, 2, 3, 4 units to the right. So this entire graph just looks like this. So this is actually your graph of f of x equals x minus 4 squared. Okay, all we did was get our parent function and shift the whole. It's almost like we picked it up and just moved the whole thing over 4 spaces. All right, so if you are still writing, feel free to press pause, but we're going to go ahead and go to our next example. All right, so let's say for this example, if we wanted to graph f of x equals the square root of x plus 3. Okay, so what I want you to do is I want you to go ahead and press pause and try this one yourself. Alright, so assuming that you've already pressed pause and worked this one out, let's go ahead and verify your answer. Okay, so starting off, we have our f of x equals square root of x plus 3. So the first thing we have to do is find our parent function. Okay, so that means this plus 3 disappears. Remove that, which leaves us f of x equals square root of x as our parent function. Okay, so that means if we go ahead and graph our f of x equals square root of x, we have our x and y axis, and our square root of x looks something like that. So that's f of x equals square root of x. Now we see here that means we're going to shift, since it's plus 3, we're going to shift our square root of x to the left 3 spaces. Okay, so if we draw our xy axis, okay, so we have our x, then we have our y, and I'm going to go ahead and draw a dotted square root of x. Okay, so we're going to get this graph and shift it to the left 3 spaces. 3, so that means it ends up looking like that. So this would be the graph for f of x equals square root of x plus 3. Okay, so hopefully that graph made a little bit of sense to you. Okay, so now we're going to look at reflections on the coordinate axis. All right, so if you're still writing this, feel free to press pause. Okay, so now we're going to look at reflections in the coordinate axis. All right, so first we're going to look at the definition of when h of x equals negative f of x. The graph reflects across the x-axis. As opposed to when h of x equals f of negative x, the graph reflects across the y-axis. Okay, so whenever you ask, okay, well, what's the difference? Think of it this way. If you multiply your function by -1, then you'd flip it across the x-axis. Okay, but if it's not multiplied by -1, then it's flipped across the y-axis. All right, so let's go ahead and do a couple of examples. All right, so let's say, for example, we want to graph f of x equals -x squared. All right, so the first thing we're going to do is we're going to find our parent function, which should be pretty obvious on this one, but we'll go through the process anyway. So we have f of x equals -x squared. That's the same as saying -1 times x squared. And just like before, we're going to remove all constants except the exponent. So we're going to remove that -1, which leaves f of x equals x squared as our parent function. Okay, now just a heads up, you may run across problems where they won't want you to graph, they literally just want you to find the parent function. Okay, so there are some problems like that, so this way you'll know how to do those also. Okay, so let's go ahead and draw our parent function. We have our x and we have our y, and our parent function is f of x equals x squared. Okay, so we drew our parent function. So go ahead and redraw our x and y axis. In this, we're just drawing a little dotted parent function. Okay, so this is f of x equals x squared. We're looking for a negative x squared. So remember, when it's multiplied by a -1, it reflects across the x-axis. Okay, this is our x-axis. Negative x squared is just -1 times x squared. So that means we just flip this one across the x-axis. So that means it looks kind of like that. Okay. So literally, if it's multiplied by -1, we flip it across the x-axis. So this is the graph of f of x equals -x squared. And again, if you wanted to erase the little dotted parent function over here just to make it a little clearer, you definitely can do that. Okay, so hopefully that made a little bit of sense. Okay, let's go ahead and do another example. Okay, if you're still writing, feel free to press pause, but we're going to go ahead and move on. All right, so let's say, for example, if you want to graph f of x equals square root of negative x. All right, now with this one, it's a little bit different than the example we did before. So we start off with f of x equals square root of negative x, which we know can be the square root of negative 1 times x. So we're going to remove that negative 1 here, which gives us f of x equals square root of x as our parent function. Okay. Now I'm just going to go ahead and go back to the previous page just for a second. If you notice here, the entire function is multiplied by negative 1 if it reflects across the x-axis. Here, our parent function is square root of x. The negative is not negative 1 times square root of x. The negative is actually underneath the square root. Okay? So because it's not out front, it's not going to reflect across the x-axis. It only reflects across the x-axis if the negative is out front of our parent function. Okay? Since it's actually inside the parent function, it's going to reflect across the y-axis. Okay, so remember, this negative is actually inside of our parent function. It's under the square root symbol, so it's going to reflect across the y-axis. Okay, so if we go ahead and draw our parent function, we have our x, and we have our y. We're going to go ahead and draw our parent function. F of x equals square root of x. Oh, move that up a little bit. There we go. Okay, so now, again, we draw our x and y axis. We have our x and we have our y, and we're just going to draw a little dotted parent function there. Okay, so we get our f of x equals square root of negative x. That's going to flip across the y-axis. Okay, so this is your y-axis. It's just going to flip right across there. So this is f of x equals square root of negative x. And again, if it makes it a little clearer to erase the little dotted parent function, you can do that. And this is our graph. And circle of that. Okay. Hopefully that was pretty clear. But let's say if we have functions that are a combination of both horizontal and vertical graph shifts and reflections. Okay, so sometimes you'll have all three you have to look at. All right, so let's go ahead and go with that example. If you're still writing, press pause. We're going to go ahead and move on. All right, so let's say, for example, we wanted to graph f of x equals x plus 3 squared minus 2. Okay, so when you see a graph like this, you know you're going to shift left, right, or up and down. Well, in this case, you're going to do both, not just one or the other. Okay. Now, before we find our parent function, we're just going to take a quick look at it. X plus 3 squared minus 2. Okay. So remember, if you have, let's say your parent function is underneath, or your value is underneath the parent function, that lets you know it's going to shift left or right. So here, lets you know you're going to shift 3 units left, just from that plus 3 under there. This lets you know you're going to shift down 2 units. Okay, so think of it this way. If you just had x squared minus 2, that x squared would shift down 2 units. But if you had just x plus 3 squared, that x plus 3 squared, or that x squared would shift 3 units left. So you're just kind of breaking it down. Okay, so now if we want to find our parent function, we can go ahead and do that. So again, just writing down our f of x equals x plus 3 squared minus 2. We have to get rid of those constants, all except the exponent. The exponent is the only constant that hangs around. So we're going to remove those two, which will leave us with f of x equals x squared as our parent function. So again, going back to that first page, we know what f of x equals x squared looks like. And really, after you kind of do it a few times, some of these common graphs will just be stuck in your head. So that's why it's good practice to draw a common graph each time you solve for the parent function, because it helps drill it into your permanent memory, or your long-term memory. Okay. So we're going to go ahead and draw our parent function. Okay, so we have our x, then we have our y. We're going to go ahead and draw our x squared. So this is our f of x equals x squared. Okay, now remember here, we're actually going to draw 2 additional graphs. You don't have to if you actually know the steps, so just to kind of show how each of them go, I'm going to draw out 3 separate graphs. Okay, so we have our f of x equals x squared, which again is our parent function. And we're going to go ahead and draw our x and y axis. We have our x, we have our y. And let's say this is our parent function here. Okay, this is 1, 2, 3. So if we want to shift 3 units to the left, that graph just shifts there. Okay, and again, if we want to erase the dotted parent function, you can. That was just kind of a guide. So this graph is just f of x equals x plus 3 squared. Okay, so we didn't finish yet. We got this part of it, so we kind of covered that up. We have this part, the x plus 3 squared. Okay, so now we have to do the minus 2. Okay, so we already did our shift left 3 units. Now we have to shift this one down 2 units. Okay, so we're going to go ahead and right up underneath there, draw our x and y axis. Move that up a little. And we have our x and we have our y. Okay, and we're going to leave off, well, start with where we left off before. So that's just about right. Oh, I meant to draw that as a dotted graph. Okay. All right, so this is your f of x plus 3 squared. So now, since we have to move it down 2 units, We just get that graph and move it down 2 units. So let's say this is our -1 and this is our -2. That whole graph just shifts down to there. Okay, so once again, if you want to erase your starter graph, you can, but this is your f of x equals x plus 3 squared minus 2. Okay, so you may want to recognize this because you may have some problems where they won't ask you to graph it. They'll actually just give you this and tell you and give you options to say, okay, how many units does it shift left or right, or how many units does it shift up or down? They'll actually just want you to point this out. So you want to kind of get used to doing that. All right, so once again, if you are still writing, feel free to pause it. But we're going to go ahead and go to our next example. Okay, now this one's a fun one. What if we wanted to graph f of x equals negative x minus 1 squared plus 1? I'll show you why I think this one's pretty fun. Okay. Now, if we look at it this way, f of x equals negative, put the second negative there, and it didn't belong, x minus 1 squared plus 1. Just like before, when you have that plus a value on the outside, you know that's our vertical shift. So this means it's going to shift up 1 unit. Clean up that 1. Okay. Now in here, of course, that's our horizontal shift. That means we're going to shift, since it's minus 1, we're going to shift to the right 1 unit. Okay. And this here, remember, it's multiplied, our parent function is multiplied by a negative number. So this actually means it will reflect across the x-axis. Okay. So this one, we have 3 different movements of the graph. Okay, so just doing a quick find of our parent function. F of x equals negative. Remember, that's the same as saying -1. -1 times x minus 1 squared plus 1. And kind of separate that a little bit. So we get rid of all of our constants that are not associated with exponents or being exponents. So remove those, which means our f of x equals x squared is our parent function. All right. So now we're going to go ahead and draw our graphs. Okay, so we draw our parent function first, our f of x equals x squared. Okay, so if we draw our XY axis, our X and our Y, remember this is our f of x equals x squared. Okay, so now we see here that we can do any one of these first. As long as you do all three, it doesn't matter which one you do first. Okay, so what I am going to do is we have our X and Y axis over here. I'm going to shift it 1 unit to the right first. Like I said, if you wanted to, you can do this one first or this one first. It doesn't matter at all. As long as you do all 3 steps, you're good. Okay, so we have our original parent function. Now I'll just put it there. We're going to shift to the right 1 unit. So let's say we'll make that 1. So we're going to get this graph and shift it to the right 1 unit. Okay. So that means this is f of x equals x minus 1 squared. Okay. So we didn't do the negative there yet. We didn't flip it. We just shifted it to the right. Okay, so that's your f of x minus 1 squared. So now, starting off at this graph on our next one, okay, so we have x and we have y. And again, this is our 1. And I'm just going to draw a little dotted graph from where we left off. So that's a little, could be a little bit better. All right, so that's our graph from this step. Just kind of moved it there. So now we're going to look at shifting it up 1 unit. Again, we can reflect it if we want to, and we'll still have the same answer, but we're just kind of bouncing around. So now we're going to shift it up 1 unit. So this is, let's say, a 1 up here. We're going to get this whole graph and shift it right up there. So we're going to get that graph, and it's going to look kind of like that. Okay. And again, if you wanted to erase the little dotted one, you could. If it's less confusing, we'll erase where we left off previously. Okay. Now this graph here is f of x equals x minus 1 squared, okay, which is where we were here. And here we shifted up 1, so that's x minus 1 squared plus 1. All right, so now the only thing we have left to do is our reflection. Okay, that minus out front. I'm going to go ahead and redraw that one. I'll move this down a little bit. Okay, so we have our x and we have our y. Okay, so let's see. We have our 1 here. We have our 1 here. And where we left off before, the graph looks kind of like that. So that's just right there where we left off before. Now, since that negative 1 is on the outside of our parent function, we're just going to flip it across the x-axis. But since we shifted it upwards, we're not shifting across the x-axis. We're shifting right where the graph is, where the vertex of the graph is. So we're just going to get that graph, and we're going to shift it like that. It's a little bit bigger than I wanted it to be, but hopefully you get the idea. Okay, so I'm going to go ahead and erase that one just to make it a little neater. And that gives us our f of x equals negative x minus 1 squared plus 1. Okay? So as long as you break it down like a step-by-step, you should be okay. It takes a little practice. So if at the end of this video it didn't quite click yet, go back, re-watch it, regraph them on your own, and it should click. All right. So now we're going to look, if you notice with these graphs, we didn't change really the shape of the graph. We just kind of got graphs and shifted them around. So here, we shifted this one to the right, shifted this one up, and we flipped this one. We never changed the shape of the graph. Okay, so now we're going to look at what happens when we actually have to change the shape of the graph. Okay, we're going to make it thinner, we're going to make it fatter, we're going to make it wider or narrow, whatever way you want to look at it. Okay, so now we're going to look at non-rigid transformations. So far, these are all rigid transformations because the graph itself doesn't change shape. Okay, so now, once again, if you're still writing, feel free to press pause, but we're going to go ahead and move on. All right. So here we're going to look at non-rigid transformations. Okay, and that just means that we actually change the shape of the graph, not just shift it. Okay, so the rigid transformations, we're just shifting the graph. The graph itself doesn't change shape. The non-rigid, we're actually changing the shape of the graph. Okay, and we do that by looking for one thing. If you have f of x and some value c is a real number, these are the things you want to look for. Number one, if your number c is bigger than 1, then f of x is stretched vertically. When what we'll call h of x equals c times whatever your parent function is. Okay, so let's say if you get a function and you multiply it by 2, that's going to stretch it vertically. Okay, or you may have the case, move that up a little bit, if c is less than 1 but greater than 0. So if let's say if c is between 0 and 1. Then f of x shrinks vertically, not is shrink, shrinks vertically. When you have the function, again, we'll call it h of x equals c times f of x. Okay, so one way to look at it is it will shrink vertically if you have either a decimal or a fraction that's less than 1. Now, if it's less than 0, then of course it's going to flip. But just between 0 and 1, that means that it's just going to shrink vertically. And I'll show you what I mean by shrink vertically. Okay, so if you are still writing, feel free to press pause once again. Okay, but we're going to go ahead and go to our first example. All right, so let's say, for example, you want to graph 3, forgot my f of x. F of x equals 3 times the absolute value of x. Okay, so once again, we're going to start off by finding our parent function. So f of x equals 3 times the absolute value of x. There is no exponent, so we're going to remove this one. Remove that 3. Which of course leaves us with f of x equals absolute value of x as our parent function. All right, so we're going to go ahead and draw our parent function. Okay, so we get our x and y axis and draw our absolute value of x. We have our x and we have our y. If you go back to your very first page, you'll see that this is f of x equals absolute value of x. Again, drawing those parent functions help out. Okay, so if we draw our xy axis again, we have our x, and we have our y axis, and we're going to draw our little dotted absolute value of x, just to show you what we mean by stretching vertically. Okay, so if you look at it this way, let's say this is 1, 2, 3, -1, -2, -3. Just to give you an idea of what we're looking at. Okay, when x is equal to 1, absolute value of 1 is 1. So we'll say this is 1. When x is equal to -1, absolute value of -1 is -1. So it's going to be, this is going to be 1 rather, not -1. Okay, so when x is equal to 2, absolute value of 2 is 2. So your y is going to equal 2. But when x is equal to -2, absolute value of -2 is still +2. Okay, so let's say this is our 1, this is our 2, we'll call this, say this is our 3, kind of number it off. So same thing with 3. If x is equal to 3, absolute value of x is equal to 3. When x is equal to -3, absolute value of -3 is still 3. Okay. Now look at it this way. We're going to get every absolute value, and we're going to now multiply it by 3. Okay, so just underneath here, I'm going to show you exactly what we mean. So you have your x here. So you have absolute value of x. And you have 3 times absolute value of x. Okay, so we have 1, 2, 3. And of course, we can do the same thing for -1, -2, -3. But we're going to start off here. So absolute value of 1 is equal to 1. We just replace x is equal to 1. And absolute value of 2 is equal to 2. Absolute value of 3 is equal to 3. So whenever we replace x with these values, this is what we get. Like I said, same thing with -1, -2, and -3. But 3 times absolute value of 1 is going to give us 3. 3 times absolute value of 2 gives us 3 times 2, which is 6. 3 times absolute value of 3 is going to give us 9. So that's 3 times 3 is going to give us 9. So now all of those absolute values, we're now multiplying them by 3. Okay, so same here. If we have x is equal to 1, we get 1. Now we multiply that by 3. That point now moves up. Same thing here. We have absolute value of 2 gives us a f of a or y equals 2. We multiply that by 3. That moves up to 6. Same thing here. So we're not going to move it all the way up to 9, but you kind of get the idea that if you multiply absolute value of 3 to get 3, that now becomes 9. Okay, and the same thing with the negative, since the values are pretty much the same. And move that here, that here. So now this graph shrinks. And it becomes, or it starts to look like this. I'm going to kind of get rid of that one since it's way off the mark here. Okay, so this one, same thing. It kind of shifts. Okay, so this one stretches vertically. Okay, the value didn't get smaller. It actually goes up, so it's stretched vertically. So this graph is actually your f of x equals 3 times absolute value of x. Okay, and again, if you wanted to erase your original graph, you could, or your parent function, you could. But this is how it will look. That just shows you that every value of absolute value of x is now multiplied by 3. So where it started off as 1 now becomes 3. Where it started off as 2 becomes 6. Where it started off at 3, it becomes 9. Where it started off as 4, it becomes 12. You know, same thing with 5, it becomes 15. So now this value, y value, is going to get bigger and bigger because you're now multiplying everything by 3. That's why it stretches vertically. Okay, hopefully that made sense. All right, but now we're going to look at shrinking it vertically. All right, so if you're still writing, feel free to press pause. We're going to go ahead and move on to our next example. All right, so let's say, for example, we wanted to graph f of x equals 1 over 3 times absolute value of x. Okay, so just like before, the very first thing we're going to do is we're going to find our parent function. So we have f of x equals 1/3 times absolute value of x. We're going to get rid of the constant, which leaves a parent function of f of x equals absolute value of x. Okay, so just like before, we're going to draw our parent function, where we have our x and our y axis, and absolute value of x kind of looks like that. So, sorry about that. Move that up a little bit. Okay, so we have our parent function. Okay, so if we draw our next XY axis, all right, so just like before, we're going to kind of give you an idea of why we shrink vertically. Okay, so let's say if x is equal to 1, then the absolute value of 1 is just 1. Okay, let's say x is equal to 3. Then the absolute value of 3 is 3. Let's say x is equal to, we'll pick 9. Then the absolute value of 9 is equal to 9. Okay, and it'll keep on going like that no matter if you go positive, negative. Absolute value of negative 3 is still positive 3, but we're just going to do a few positives. Oh, shift that up a little bit. Okay, now let's say we go ahead and graph those. Okay, so if we'll draw that out. Okay, so this is our absolute value of x. I just drew it a little bit bigger. Okay, so this is our absolute value of x. Now let's say if we get, this is our 1, we'll say this is 3, and I know it's not absolutely perfect, but we'll say that's 9. Okay, so remember, absolute value of 1 is 1. Absolute value of 3, 3. And absolute value of 9, we'll say that this is 9. Okay. Now imagine if we now get all of those values and multiply it by 1 over 3, which is the same as dividing it by 3. Okay. So if you have absolute value of 1 is 1, you multiply that by 1/3, you get 1/3. So now this x equals 1 now becomes x equals 1/3, which is about right there. See, it's shrinking vertically. It's going down. It's not getting bigger like the one before. It's getting smaller. Okay, so the absolute value of 3, we know that's 3. Now, if we multiply that by 1/3, 1/3 times 3 is 1. So where the absolute value of 3 is 3, multiplying that by 1/3 drops it to 1. Okay, same thing here. We have our absolute value of 9 is 9. We multiply that by 1/3. 9 times 1/3 is just 3. So where this started off, let me go ahead and make that a 9, make that a 3, that's still a 1. Like I said, I didn't make it all the way up there because I didn't want the graph to get ridiculously big. But where it started off, its absolute value of x is 9, multiplying it by 1/3 now makes that 3. Okay, and it will be the same thing for the negative, -1, -3, and -9. Move that over a little. Okay, so now this graph has shrunk. Uh-oh, trying to make that kind of drew my little dots here, but hopefully you get the idea. Okay, so you have this one, and this one. Okay, and it will be the same thing for the negative values. Kind of. There we go. Okay, so remember, every value of absolute value of x now gets smaller. So that's why it shrinks vertically when multiplied by a number that's less than Okay, so this is now your graph of f of x equals 1/3 times the absolute value of x. Okay, so hopefully these examples made sense. And remember, this can get kind of complicated, so if you need to, rewatch the video, do the example problems on your own, learn the process. Once you get kind of good on the process, everything else is just practice, but it's just getting to know the process. Okay, so I will see you on the next video.